Huh? So security is the next topic. Now security topic is going to be a natural extension of what we discussed yesterday. So what did we discuss yesterday? This is my Unix machine, let us say, or a Windows machine. So this is my host, or this is also called as server. And inside this server I have one database. This is my database, and the name of my database is Focus1. And inside my database there is a user called as user UA, UB, user B, and user C. And obviously there is going to be a user called as sys, and there is going to be a user called as system. So these are always there along with some additional things. Sys, we saw yesterday, contains list of all the data dictionary tables and data dictionary views. Those are owned by user sys. System is some additional views which are not as important as sys, but system is also an important schema there. So now today what are we going to learn? Some simple basic commands. Now we know the concept of a schema, we know the concept of a user. Schema and the user is one and the same thing. When you log into a database, you are actually logging into a specific schema of that database. You cannot just log into a database, you have to log into a specific schema of that database. And when you do that, you will be doing all the activity within that specific schema. You will be creating tables, you will be creating views, dropping views and all that stuff within that specific area. That will be your own world. So now today we are going to see that a new user joins your organization, a new employee joins your organization. How are you going to create a user ID for him or a schema for him, and how do you manage all that stuff? So user administration related things, those basic things. How do you lock an account? How do you unlock an account? How do you find out how many accounts are there, or account in a sense, schema. How many schemas are there in your database? And then how do you assign a table space to an account? So that is something which is we're going to learn today, a different thing. So all those things that we are going to learn today. So first thing is how to create a user. So now I'm going to use the word user instead of schema, but it's one and the same thing. How to create a user. So there is a command, obviously, to create everything. There is a command called as create user. Name of the user, let us say Shekhar here. So user will be created. Now we are going to, so we can give a semicolon here, but we are going to give some more information instead of just finishing this thing, because when we create a user we need to assign a password also. So password is assigned like this, identified by and the password, PASS. Now passwords are case sensitive in 11G. They were not case sensitive until 10. So you need to make sure whatever you type in there, maybe in single quotes, it will help you to make sure that the passwords are properly written over there. You can use the exclamation mark and all those things in the password. Special characters are there. So identified by password. This is how you assign a password. Then there is one important clause here, which is default table space. And the name of the table space I'm going to give here, TS1. Let us say TS1 is the name of my table space. Now we don't know the concept of a table space at this time. What exactly is a table space? Table space is just a logical concept. At this point, just think of it as a logical concept which will allow me is the user now, which will allow a user to put his objects into that place. So if I create a table, if I create a cluster, if I create an index, all those things which require a hard disk space. Okay, let me repeat, all those objects that require hard disk space, those objects only. So that's why I said only 3 objects. Tables require hard disk space, then indexes will require hard disk space, clusters will require hard disk space. We don't know too much about clusters, so right now just think about tables and indexes. These things require space on the hard disk. So these objects are now created inside a logical concept called as a table space, and the name of my table space is TS1. So I'm going to say now, this is my database Focus1. In this Focus1 database there are these different users, and this database Focus1 is associated with, now I'm going to say now for the lack of a better diagram, I'm not a good artist here, but this is a table space called as TS1. This is a hard disk now, and this is a table space called as TS2. These two are table spaces that are associated with this database Focus1. The table spaces are associated with a database. Okay, so focus one has two table spaces. Now this table space may be of 100 gigabyte size, this may be of 50 gigabyte size. Sizes could be different, and whose job is it to create a table space? It is a job of a DBA. DBA is any user who has been given special privileges to create these table spaces. So what a DBA usually does, he will create a table space which is some space on the hard disk. That space will be of, in this case, 100 gigabytes, and this case it would be of 50 gigabytes. The names are given to that space, and that is what we call as a table space. Now that is created first, table spaces are created first, and after the table spaces are created, you come and say create user shaker identified by the password, whatever password you want to give, and default table space is TS1. When I say default table space, it means every time user shaker, now let us say this is shaker, every time user shaker logs into his account and creates any object that requires a disk space, tables and indexes, let us say, then that object will be physically stored inside this table space. That object will be physically stored inside this table space, which is a space on that hard disk somewhere. That is what a table space is. By default, it is created over here. If I had said default table space is TS2, the table that I would create will actually go and sit over here. It will occupy the hard disk space in the TS2 table space. That is the concept of a table spaces. And why this concept was designed, there are probably so many advantages for a table space, because when we talk about backups, for example, when we talk about backups, we can just back up a table space very quickly. That is why table spaces are created. In certain other databases, for example Microsoft SQL Server, there is no concept of a table space. And we have that concept in Oracle of a table space, because it is going to solve so many problems for us, taking table space offline, bringing it online. When we take table space offline, it means what? That means nobody can access anything in that table space. Even if you are logged in as user shaker, you cannot access your own tables. That is something that can be easily done, because we have a command to take the table space offline, we can have a command to take the table space online, we have a command to back up a table space, we have a command to restore a table space if something has gone wrong. So all those commands are now created, all those concepts are created, and that is why table space is a very important concept in the Oracle's point of view, from the Oracle's point of view. So why it is created? For the ease of administration, that is number one, and our objects that require disk space, they go inside here. Okay, so that is what the TS1 and TS2, those are the table spaces. So that is the discussion. We are going to go into a lot more discussion of table spaces, how to create table spaces, how to increase the size of a table space, how to decrease, how to take it online, offline, all that stuff. We are going to go into much more detail. But at this time, let us just understand it is space on the hard disk where our database objects are stored. That is what the hard disk table space is. That is what the table space is. Then the next thing is temporary table space. The temporary table space is maybe TMP1. This is a name of another table space. Let us say now, instead of TS2, I will type here now TMP1. Okay, TMP1. So what is this table? This is also a table space, some space on the disk of size 50 gigabytes. I am assigning that table space to this user as a temporary table space. What is the meaning of this? It means at any point of time, this user is writing some crazy code, like some PLSQL code, forget about PLSQL code. If he is doing some kind of a join between two tables. Now when we do joins, many times there is a intermediate table, depending on the complexity of the join. An intermediate table is created behind the scenes without we knowing it, and that table has to be kept somewhere. Where is that table kept? It's a temporary table, so it is kept inside some hard disk space, and that is over here. So temporary table space has many purposes. One of the purposes that I explained to you, anytime there is a complicated complicated operation, in this case join of two tables, a temporary table could get created and it is stored inside this thing. Another reason for creating a temporary table space, when we do sorting, okay, when we type a command select from some table, blah blah blah, and finally we say order by employee ID. Now if the employee ID is if the employee is a very huge table and there are around 4 million employees to be sorted, sorting is a very complicated operation, and in that sorting operation many times it is done using a typical method of divide and conquer kind of a thing. So 1 million rows, first they will be divided into smaller chunks. Those smaller chunks would be sorted, and that sorted data is kept somewhere temporarily in some temp table, and that is over here. Okay, there is a lot of other complications that happen behind the scenes, but for temporary operations that user is doing without knowing that he is doing it, those things are kept inside the temporary table space, and the moment your operation is finished, moment your select statement finishes, your ordering order clause is no more important anymore because the data has been displayed to the user. This temporary table space will be either overwritten, will be wiped out, all those internal things will happen. So it is all temporary data there. This is permanent. Nobody will delete it unless and until we delete it using the delete command or the truncate command and all that stuff. So that is what a temporary table space is. So temporary table space is temp1, and then next thing is quota, 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 and I'm going to say 10 or 100 MB on now this time I will say TS. Okay, this was TS2 na? So let us keep this as TS2. TS2. Let us keep it simple. So what I'm saying that yes, your default table space is TS1. That means any object that you create will be stored inside the TS2 table space. It will take the disk space from the available 100 gigabytes in this case. But out of that 100 gigabyte, you have been given quota only for 100 megabytes. You have been given quota. Shekhar user will not be able to create any table bigger than 100 megabytes. Can he create multiple tables in that 100 megabyte? Yes, he can. So I will create a table A, I will create a table B in my own schema, and table A will be stored inside my default table space. Let us say here, table 2 is also, some part of table 2 is here, and maybe table C is also here. All that combined will never go beyond 100 megabytes. That is the quota that has been given to a user. So this is what the quota is. Usually this quota is given as unlimited. If the user is very important, if the user should have access to all the 100 gigabytes in that, then he is given an unlimited quota on this thing. Or if you don't even specify this thing, these are all optional clauses by the way. If you don't specify this thing, the quota would be unlimited on any table space that has been given to him. So these are certain things. Create user, identified by the password. Default table space is TS2. Temporary table space is temp1, and quota unlimited on a specific table space. Now this is a command with a semicolon ending, and this will create a user. When a user is created, what happens? It is actually an account that gets created inside our database, and the entry is made into a data dictionary view, and that data dictionary view is DBA_users. So if you go and say select username, the name of the column is username. Select username from DBA_users, you will suddenly see Shekhar there, because we have just created a user called as Shekhar. How do you drop a user? You just say drop user Shekhar and a semicolon there. So this will drop a user. Now dropping user is not a very commonly used command, this will be kind of a rare thing for you. Now if you have certain objects which are already created in user Shekhar, then the user Shekhar will not be dropped. It's like if you have a directory on Unix that contains certain files, then you will not be able to remove that directory using the rmdir command. Similarly, this is there, and there are extra clauses to this thing which can drop the tables and then drop the user also. Once the user is dropped, an entry in the DBA_users is removed. So there is a lot of information in the DBA_users over there about that specific user. So this is our typical way of creating a user. And who can create a user? Now who can create a user? A user, let us say user UC, can create a user called as Shekhar. Okay, provided that user UC has a privilege to execute a command create user. So you need to have a privilege to execute a specific command, in this case create user. Then UC can create a user called as Shekhar. If UB user has the create user privilege given to him, then he will be able to create the user. So anybody can create a user. So that way the concept is very simple. You give the privilege to execute a specific command, and that user will be able to create whatever other users are there. This is a simple concept, but this is not usually done. There are certain users which are identified as DBAs, and only those users are given the privileges, and you would be working as a DBA in any of the organization there, and you would have privileges to create the users. So that is the concept of a user there. Now when the user is created, very common tasks for DBAs are to change their passwords. So if the user has forgotten what the password is, you can change the password using the alter user command. Alter user Shekhar identified by, and the password, whatever new password you want to give. This is how you change the password, and not just change the password, this is how you actually change any other property. If you want to change the default table space, if you want to change the temporary table space of that user, if you want to change the quota of that user, you use the command alter user. So alter user Shekhar default table space TS5. Now the default table space will be changed, and from that point onward, any new object that is created by that user Shekhar will go into the new table space. The older objects are still going to be in the previous default table space. So this is how the alter table. So we have seen three commands. We have seen a create user command. We have seen an alter user command. Create user and alter user command are very similar to each other. Whatever has been created, assigned, can be altered by the alter user command. And drop user is going to drop the user with all the things. And we have also seen what the concept of a table space is. So this is the kind of main thing about the user creation. Bolo.
You said about the quota space in TS1. So if you want to change the unlimited to certain particular amount of space, then how to do this? After creating the user.
After creating the user, alter user then. Alter user Shekhar, quota 500 MB on TS5.
Okay, so if we want to modify a user, then we have to
use the alter command, yeah. To modify the quota, to modify the password, to modify the default table space, to modify the temporary table space, for that the command is alter. All of them. So this is the concept of a user, a very simple concept of a user. So now we will go to the next concept. So we'll